going to start here with what we're going to call a stage and assemble that to a stand. And now we're going to mount it to the stand. 4 screws under the bottom of the stand. Now that we've got the stand assembled with the base, everything's in place, we're going to go ahead and mount the motor unit. You can see you've got a lot of mounting options here as far as your height. There. Now, the basic structure is assembled. Now we're going to take a look at the solder head itself. Alright, we're going to take a look at the Avio Super Welder NA153. We're going to pull the covers off of the unit to get to the mounting holes to mount this to the motor unit, and also to install the displacement sensor. 2 screws on the faceplate. The faceplate will come off, and then there's 2 screws in the sides. That's all the covers you'll need to take off. Take a look at it. Now you've got access to the 4 mounting holes. Again, on the front of the motor unit, you've got options as far as mounting height. And again, we're going to start high. Let you take a look at this. There we go. When you mount your displacement sensor, pull the covers off of the rod, remove the rod, okay, we're ready to mount our displacement sensor. The first thing I'm going to do is put our 2 set screws in. That's going to retain this inside the head. one here. Just going to get these started. Another one here. Now the rod for the displacement sensor has got two lines and a dot. The dot is going to go down toward the bottom. The displacement sensor itself is going to go into a recess here in the machine, in the head. We're not going to tighten up the set screw, we're going to drop the rod in from the top, and you'll see it come through the bottom. There. Now this displacement rod is seated all the way down into the head.
Okay, so one of the issues that we encountered and that you should be aware of is that the displacement rod, when it passes through this piece right here, that bolts up right here, the displacement rod must have the ability to seat all the way down on this surface. You can see how it's sitting there now. What we discovered in putting this one together, the first one that we did, is that the hole right here that the displacement rod goes through had some burrs in it from this tapped hole that goes in for the set screw, and it wasn't allowing the displacement rod to seat all the way, and so you get an absolute displacement readout when you first fire up the machine that is out of the recommended range. So what we did was just ran a little drill by hand, twisting it by hand through this hole and clean the burrs out so that displacement sensor can seat through that hole now. When you do this, you got to be very careful that you don't lose the washers and stuff that are underneath these the heads of these screws here. So I'm going to reinstall this, lift the displacement sensor back up, and start these screws back in here. We just had to disassemble this little piece here in order to do this. And then there's this sensor rod right here that has to go back up in here like this. This is all somewhat tedious work. Alright, so I'm going to tighten these down here, and they don't have to be very tight, just properly seated. I'm going to make sure that this sensor rod is straight right here, so that has to be straight and go up into the sensor. Okay, so in putting this back together, what we discovered is that it's helpful if you loosen these screws right here a couple of turns before trying to insert the displacement rod. It somewhat helps things to line up. You need to be able to look underneath the displacement rod here and see that it's resting on this surface right there. The other thing is that the pressure on this unit right here needs to be applied so that it then closes up this gap right there, so you know that that's resting there. And then at this point, I'm going to put this set screw in here. I'm going to lift up very slightly on this rod. It's only supposed to be between 100 and 300 microns off of that black anodized block below. Okay, we're going to continue on with the installation of this equipment. For starters, when this arrives, these screws will be in place, so we'll need to remove those. The cables come with two different hole sizes. The larger size goes to the unit over here. The smaller one goes under these smaller screws. The manual indicates that it's important that the ends of these cables, this metallic end, only touches these square pads right here and does not touch any of the rest of the machine around it. So when you install these, you need to check and make sure that there's not any sort of an issue there. As with all the connections on this equipment, the bolts don't need to be super tight. Just snug them up and that's sufficient. Over tightening could cause them to be stripped out. Okay, on the other end here, these actually install on some holes that go right through the ends of these metal pieces. So you use the smaller set of bolts and the smaller end of the holes. And here again, this doesn't need to be super tight by any means. Okay, we're going to review the electrical connections on the back of the power supply here. Of course, this is where the 220 main power comes in. I'm not going to disassemble this. This should be done by an electrician if this arrives with the unit uninstalled here. You got a motor connection. You have the actuator connection right here, which would be basically it runs the thermocouple. This is the motor displacement cable. And of course, here's the foot switch, connects to these contacts here, and it actually says foot SW right here on the machine, so it's pretty easy to see right where it connects to. The manual does indicate that it's important that the actuator cable and the motor displacement cable are not routed close together. They need as much separation as possible. So try to keep these routed and separated when you install this at your facility. Alright, you have some options for how to route wires on this. One option would be to route this wire through these right here and use basically those little plastic straps. Or the unit comes with some strain reliefs like this, and those would actually screw on right here. So there's several options there. Whatever you do, you need to route with a looped wire here that's large enough to allow this to move up and down without pinching the wire. Okay, the motor drive attaches right here, and there's actually two screws that connect these two connectors together. Very important that those be connected, or else you'll get an error, of course, when you turn this on. Okay, so here's how you know if you have that rod installed correctly. With a little bit of pressure applied on this, and this gap closed up and the rod installed, power up. Of course, you have to have the thermoed in, thermocouple attached, and so forth for everything to reset right. Push the parameter button and push the next button. It brings up this screen where you can read a sensor absolute position. Now in this case, our sensor absolute position is 7,430 microns. What that means is that your rod is actually installed too low. It needs to be raised. So what we're going to do here is release this set screw. And we're going to take a pair of tweezers and we're going to raise the rod up until we get over, it's 800 and something here. When we get a reading right there, you're getting a reading of about 200 microns, 170, 180, that's good. Tighten the set screw down as long as you're between 100 and 300 microns. Then don't forget to tighten these screws back up that hold all this assembly together once you get that rod adjusted to the right depth. It's all got to be snug back up so everything works properly. Alright, so then we got an absolute sensor position of 182 microns. That's between the 100 and 300 recommended in the book. Everything's happy, and of course that position changes as the head rises, you can see. But that needs to be the starting position when everything's down and seated properly right here. So then at this point, of course, we can put the covers back on very gently around these wires here. Of course, everything needs to be done very carefully so as not to pinch or cut any wires. And of course, when the screw is installed on this left side, it actually needs to go through the bracket that holds this thermocouple socket. Being very careful here not to stress any of these wires. So we screw that back on. And there's a front faceplate here that has to go on. I'm just going to double check some of my screws here and make sure everything got tightened back up properly. Route this wire in here. And there we have it. Alright, moving on to step 10 from the manual. After we've identified that we have the correct range for our absolute position, we need to take the jog handle, which this right here has two functions. It can turn and you can press it. Right now it's scrolling through different screens, and we're trying to get to this point right here where we want to set. After pressing the jog handle, we actually need to press the enter button to make it take this number into the 0 position. Should read pretty close to the same. They might be a digit or two off, but they're pretty close. When you get this, press enter to confirm. And after pressing enter, we press the operate button, which brings us up to this screen right here. Now at this point we want to turn the power off on the main unit. Now then, we flip the power back on, boot it back up. Now we're going to press the data set key that shifts us into the data set mode. Press the parameter key. This is how we scroll through the screens with the next. Okay, so I'm going to run through the process of how to set this up. Well, basically, there's two different parts of this that need to be set up in order to operate, and the first one is, of course, the heating profile. Now, basically, you hit data set and go through the screen, and this is where you set your heating profile. And I realize it's difficult to see this on the video, but there's a preheat setting which allows you to bring the thermode up to a certain temperature, and it gives you an uptime. This is how many seconds it's supposed to take in order to get to that temperature. There's a first heat, a second heat, a third heat, and a fourth heat. You don't have to use all of these, but you can. They're there for your use if you want them. Right now I have a preheat set at 95 Celsius, 2 seconds to get there. A first heat set at 200 Celsius, 2 seconds to get there. And a second at 300 Celsius, 2 seconds to get there, which is the uptime, is how long it takes to get to that temperature. And then the main time is how long it's supposed to hold that temperature. So then at this point, if I wanted to, define a certain cool-off profile or whatever, I could go and enter lower temperatures here and how long it's supposed to take to decelerate or to drop the temperature down to those numbers. So anyway, and the way you edit this stuff is basically it's all done with this knob here. Right here, we're up here at the program where you're setting the numbers. As you turn this knob, it's called the jog knob, it cycles through these screens, and anywhere you stop over a number, if you press it, it activates that number. Like right there, I'm changing it from 2 seconds to 3 seconds on the uptime. When you press it again, it sets it, and you can continue to rotate this, and it just basically scrolls the cursor through the numbers. So I've got a heating profile set there, and we'll leave that like it is for now and move on. If we go into the next button, we're looking for this page right here where it has the motor position and displacement. And this is where you set up basically how you want the thermode motor to behave as far as how far you want this to come down in the sink and so forth. Now, basically in setting this, there's 3 parts of it that have to be set. The decelerated position, the lower point position, and the reference position. Those are the ones that the manual basically covers. So anyway, to do this, what you do is you put some dummy work on the table, which in our case, I've just got a block of metal here that's going to represent whatever it is that we were trying to solder. And it's sitting on the stage here. So I'm going to scroll over to decelerated position, press the jog button, and go down to sequence setup. Now, above sequence setup, there's this thing called decelerated height, and it's set at 2,000 microns. And basically what that means is 2,000 microns or 2 millimeters above the work height, this thing is going to start decelerating. It's going to rapid to that point to 2 millimeters above, and then it's going to decelerate as it comes down and touches the final workpiece. The process of setting this up, this thing is going to home itself. It's going to come down and sense where the workpiece is, and it's going to do that with each of these setup positions as far as the decelerated position, the lower point position, and the reference position. So at this point, I put the cursor on sequence setup, hit enter. It brings up this little screen here, and the motor button is flashing, and that means that the motor operation is disabled. It's a safety. It kind of resets itself every time. So you hit the motor button, it becomes solid light. This switches to enabled, and now as I go enter, there's 6 steps it's going to go through here, and as you hit enter, it's going to take you through the steps. First one right there, it homes the machine. You see the head come up. Second one, it's going to come down and sense where the workpiece is or where the product is that we're trying to heat up with this. Okay, so right there it sensed where the workpiece is. One more, it moves to the sink amount. Basically, you just go through these screens and it kind of cycles the motor through the different positions. And after the last one, when it goes away, that little screen goes away, you hit stop reset, pops you back up here where you can go through to the lower point position. Now at the lower point position, I'm going to press the jog button, and right here is our target sink amount. And what this means is, from where it senses the very top of the workpiece at, how far do you want it to sink as it's going through its reflow soldering or ACF bonding cycle, whatever the case might be. Right now we have it set at 200 microns, and of course it'll only sink that if the workpiece, actually gave way under it as it was heated the way solder pads would do. It's not really going to sink that much because we're sitting against a piece of steel here when we cycle it. But anyway, you could highlight this and control your sink amount, and that's kind of what the purpose of the displacement sensor is. But for this purpose, I'm going to leave that on 200 microns. I'm going to go to sequence setup. Press enter. Motor button is flashing again, meaning it's disabled. Press it, enables the motor, and then enter. It's going to home it, go to the origin first thing, and comes back to that position. Now it's going to come down and sense where the workpiece is again. Now at this point it's sensing the plane where it first touches the workpiece, and that's how it measures how far you want it to sink from there, or how much displacement you want during a soldering cycle. And as this thing completes each of its little calibration steps, I just keep hitting the enter button on the keypad here. And the last one, it goes away. I hit stop reset, and it backs it out where when I turn the jog button, it jumps down to reference position. And this is the last one that we'll set up here. I'm going to highlight that. I'm going to come down to sequence setup. And once again, the motor button is flashing, meaning the motor's disabled. Press it and enables it, and enter, and we're going to go through its different functions here. It's going to home first, or go to the origin. Beeps at us when it's done with each step. And I keep hitting the enter button. I'm sorry, on this one I'm actually supposed to remove the workpiece, and I should have done that before I started, but I'm removing it now. This reference position is actually where your work table is. It wants to know what's the farthest it can go, and this is how it knows how to sense when a workpiece is not present. If a workpiece is not present, this will come down until it touches the work table, and then you'll get an error because the machine knows that your piece that you're trying to solder wasn't there because it went too far down. So pressing enter, going through its different registration sequences. Stop reset pops me back out of that. At this point I can click on the operate button. That stores the information that we have entered as far as where everything is at. So the motor knows where the workpiece is supposed to be, it knows where our work table is, and it knows where its return position is. At this point in the operate mode, and you can see we're in that mode because the light's lit up, we press the origin button. It asks if you're sure, you enter for yes, and it's going to home itself. And now at this point we're ready to do a test run and heat the thermode up according to the data and the motor positions that we've entered. Alright, so we've entered a heating profile and we have registered our motor information, our sink amount, and the various other things that you need to set for the motor. I'm going to put our workpiece back in here and line it up where the thermode will touch it. And at this point I should be able to actuate the foot switch, and this will run through a heating sequence. So it comes down, it touches the workpiece. And you can see it begins to graph the heating profile here as far as what temperature we're going to. There it's reached the 300 that we set, and it's cooling off from that. And when it's done, it should retract. And there is a certain temperature that we can set in the temperature settings that tells the machine at what temperature it's allowed to retract the head. Alright, so one other thing that's worthy of mention here, under data set in the heating profile, you understand what we're talking about here, preheat, first, second, and so on. These are different stages of heating that you can make this profile take. The uptime is the time that it takes to get from the previous temperature position to the one that's set wherever you're setting at it here. In this case, in order to move from the preheat to the first temperature, I have 2 seconds in there. One other setting that's of worthy note here is a temperature limit, which is, in this case, 600 Celsius, which could be changed. And that's kind of like an over temp limit. If it hits that number, it's going to reset the machine. It's going to shut the cycle down. The other one is this solid 0.1 or solid PT1. This is the temperature which the thermode has to cool down to before it can retract. And that right now is set at 150 Celsius. So let's go into operate mode, and I'll actuate this with the foot switch, and you can kind of have a look at the heating sequence here. Alright, so right now it's reading the thermocouple. It hit 200 degrees, it hit 300, it leveled off, it holds it for 2 seconds, which is what we set. And then it begins to let the thermocouple cool, and you can see this on the graph. When it hits 150 degrees, right there, the head's going to retract. And that's that solid 0.1 that we talked about.